Okay guys, let's take a look at today's lesson. We're going to work with calculators, yay, and parametrics. What a great combo, right? Parametrics and calculators. So we're going to work with both of those today. In a particular instance, and that's with projectile motion type of problems. So we have a set of parametric formulas that will basically model this type of motion. And so let's talk about these two formulas. They are formulas that you would need to memorize, to use on a quiz or a test. So let's talk about them individually. So the x component, or the x portion of our parametric equation, the v naught means initial velocity. Okay, we're probably familiar with that concept. V naught would be initial velocity. Notice how the cosine is paired with the x. Right, so when you're memorizing your formulas, I'm just trying to help you, the cosine is paired with the x. So we have v naught cosine theta t, so there would be a variable t, plus x naught. Now this variable is very rarely used. We don't use it very much at all. What it would indicate is a displacement or a change from some kind of a horizontal location. And we really don't normally do that, right? Well, I'm going to be standing here, but I'm going to start my equation over there. So we normally don't use that, but that's where we would put one if we had some kind of a horizontal displacement. We would put it with the x naught. Then our y equation, notice how it starts out with a negative 1/2. So the negative 1/2 is just part of the formula. And a would be acceleration due to gravity, and that's probably a number that you're familiar with. Like if we're in meters, it's 9.8. Does that sound familiar? If we're in feet, it's 32. Right, we remember that. So that's just that a would be acceleration due to gravity. And then you have the t squared. Then our next little part right here, we have v naught, which again is initial velocity, sine theta. Notice how, again, the sine is paired with the y. That would kind of make sense for us. And then we have the variable t plus y naught. Now this particular one is used quite a bit. That would be like displacement from the ground. Like say we are, kicking, well, let's say we're throwing something. We're throwing a ball, and the person's however many meters high or feet high. That would be our initial, height of whatever it is that we're throwing, or maybe we're doing something, I don't know, throwing something off of a building. I mean, who knows? But this is a more common variable to use, the y naught, which is our initial height. So let's talk about the angle. The angle is very specific. It has to be the angle of elevation. Angle of elevation is made with the horizontal. Sometimes you're going to be given an angle that's made with the vertical, and you would have to convert it. You would have to change it to an angle of elevation for this formula. So just be aware that it needs to be angle of elevation. So in other words, it needs to be the angle with the horizontal surface. Okay? So that's the formulas that we're going to be using. Any questions about the formulas? So it's just something that you would memorize. I don't think it's real difficult to memorize them, but it'd be pretty important to do so. So let's talk about, we're going to be using our calculators, and we're actually, unfortunately, I think, we're going to have to travel back and forth between parametric mode and function mode. We can't get everything we want in one mode. So it does take us a little bit longer to do these kinds of problems because we have to go back and forth. We have to go from function mode to parametric mode and back and forth. So that is just a little bit of an issue that we deal with time-wise. So let's talk about what we're going to do in each mode. What are we going to do in function mode? What are we going to do in parametric mode? So the pros and cons. So function mode, this is the mode we're most familiar with. We've used for quite some time. On function mode, we can do a lot of things. We can calculate the zeros, intersections, maxes and mins, values. We have a lot of availability on function mode for those types of calculations. But when it comes to horizontal displacement, it will not do that. In function mode, we only can put a y equal equation, right? We can't put an x equal equation. So we can't calculate any horizontal distance whatsoever in function mode. Otherwise, that would be the mode that we would stay in all the time, right? Because it does all these other very cool things. Parametric mode, unfortunately, the pro for parametric mode is it does calculate horizontal displacement. That's really what we use it for, is horizontal displacement. But it will not do all these other fun things. It won't calculate zeros or maxes or mins or intersections. It would be great if we could have one that did both, but we actually don't. So we're going to have to travel back and forth between those two modes as we work our problems. Okay, questions so far? So I have a couple of different examples. So let's go to our slide, our second page, so we can look at our examples. So I'm going to go ahead and write our equations up here. It's just as a reference for us because we're going to be writing our equations. So our x equation is v naught cosine theta t, and then plus x naught if we have one. Neither of these problems have of x naught. So our y equation is negative 1/2 at squared plus v naught sine theta t plus y naught. Okay, so those are the equations that we're going to be substituting into when we write our parametric equations for these problems. So let's look at the first one. We have a ball thrown horizontally at an angle of 45 degrees from the top of a tower at 30 yards per second. The tower is 45 yards high, so now we are being asked to write parametric equations to simulate the motion. So let's do that. So we have an x equal equation. So v naught is our initial velocity, and our initial velocity here is 30 yards per second. So 30 cosine, and our angle that we've been given is 45 degrees. And so that is times t. We're really not going to mess with any kind of a horizontal displacement. There's not going to be an x naught, so we're not going to worry about that. So now let's look at our y equation. Our y equation is negative 1/2, and then we have the a for acceleration due to gravity. Well, the number that we've memorized is 32, and that's for feet, right? And we're in yards. So we're going to have to make an adjustment to that 32. What would we do to adjust it to yards instead of feet? We divide by 3, right? So we're going to do, it's going to be 32 divided by 3. And then we have t squared plus, and then again our v naught is still 30, but we're looking at sine of 45 degrees t. Now we do have an initial height, don't we? Our initial height is, 45 yards. So our y naught is going to be 45. Okay, so really important that we get the equations down. Are we okay with that, subbing in? If our equations are wrong, we have no hope of getting any correct answer, right? Yes. A is acceleration due to gravity, so it's just a number you have to memorize. If it's in meters, it's 9.8, and if it's in feet, it's 32. So you just have to memorize those two numbers for A. Okay? Anything else on those? All right, so let's look at what they're asking us to do. Part B, find the maximum height the ball traveled. Find the horizontal distance traveled when the ball reached its maximum height. Okay, so it's using the word maximum. So let's talk about the two modes just kind of briefly. So I have a function mode and I have a parametric mode. So let's talk about the function mode first. What do we measure on the y-axis when we're in applications like this? We measure the height, right? This would be height. But when we're in function mode, this right here would be time. Okay, that's what my axes mean if I'm in function mode. So I can get height and I can get time. When we're in parametric mode, I can still get height right here. So that's kind of a duplicate for us. We can really go to either mode to get our height, depending on what we want. But in parametric mode, what does this give me? This x-axis doesn't give me time, it gives me horizontal distance. So we have to keep those things in mind as far as which mode we need to be in as to what we're looking for. Right, if I want the maximum height, well, I'm going to have to be here because parametric mode doesn't do maximums for me. I can't do a maximum in parametric mode. I'm going to have to be in function mode if I want a height. Excuse me, a maximum height. And then we want the horizontal distance. Well, that's going to happen in parametric. Okay, so let's start out in function mode, and I'm going to have to erase this. Is everybody okay? Okay, I have to erase this to pull the calculator up. I've actually already input those equations into my calculator just to save some time. So we're going to go to function mode. So we go to our mode. Let's make sure we're in function mode. Make sure that you're in degrees, because if you're in radians, it's going to, it's not going to work right. So we're in function mode. And I go to my y equal, and I have my equation. I didn't even bother simplifying the negative 32/6 because the calculator doesn't care. I didn't want to inadvertently make some kind of a rounding mistake or something. So I just left it like that. My y equals is in there. So we really don't know what the graph is going to look like. So I would just do a zoom 6, so zoom standard, just to kind of take a look. It's probably not going to work. See, I don't see the y. I need a maximum height, right? So I'm going to really need my maximum value. So I like to adjust the window by hand. I don't like to do the zoom fit and such, but you can do whatever you like. I would go and change my y max to maybe, I don't know, 100. I mean, I don't know what it's going to be, but I bet 100 would probably, not 1,000, but 100 would probably be sufficient. So let's look. Yeah, 100 is sufficient. So now I can see my maximum height. So now I need to do my max finder, right? We know how to do that. So that would be second calc, right? Our 4 is maximum. And so we would go to the left and to the right. There's to the left. And then to the right. Okay, so what it's giving me my maximum height, which is fantastic, but it also is giving me another piece of information that I have to have, and that's the time that it occurred. I need both of those. So let me show you what you're going to show for work. These are calculator problems. Sometimes students struggle with what am I supposed to show. I'm going to show you everything you're supposed to show, okay? So you would say that the max was at time 1.988. I'm going to, that's in seconds, and I'm going to equate that to A. And I'm going to store this in A, and I'll show you why in just a moment. So what I am also working with you on are calculator techniques that are going to be important for you in calculus. We do these types of calculator things that will help us in certain applications, so we need to know how to do this. So my max time is at 1.988. I'm going to store it in just a moment. My maximum height is at 66.094. What are we in, yards? We're in yards. Okay, so I have my max when it happened, and I have my max height. So now what we're going to do is your calculator stores numbers in X. That's why you never ever use X to store in. Okay, so what we're going to do right now, your calculator believes X is 1.9887. That's what your calculator believes X is. And it also, by the way, believes that Y is 66.093. If you did alpha Y, you would have this value stored in alpha Y. Okay, so what I'm going to do, we're going to go out, going to go to a clear screen, and I'm going to store this time because I'm going to need it. I'll show you why I'm going to need it in just a moment. So let's go to a clear screen, and I'm going to type in X and then enter. And you can see that my calculator believes that that's what X is. It's 1.988. So I'm going to store it, hit the store button, come on, in alpha A. I'm just going to store it there. I've equated this to A, so now every time I write the letter A, it's going to mean this number. Okay, that's what it's going to mean, is that number. So it asks us, we got the maximum height, find the horizontal distance traveled when the ball reaches maximum height. So now we need to go into parametric mode. We need horizontal distance. That's the only place where we can find horizontal distances in parametric mode. So let's go to our mode button and let's change to parametrics. And we would go to y equals, and we would enter both of those equations. I actually already have, just for time's sake. Our equations are right there, 30 cosine 45t. Students earlier were forgetting to write the t on these, so please be sure you're writing a variable there. And then our second equation is in our y equals. So now I'm going to show you a different way, a very helpful way to find the value of x. So let's go to a clear screen. And what I'm going to do is I'm going to pull down I'm going to ask the calculator to use that x component. And the way that I do that is I do alpha calc. See how I have all these options right here on what to choose? I want to choose my x1, right? That's where I have my horizontal equation in. So I'm going to hit enter to choose my x1. And I want it evaluated at a. Right, I want it evaluated at a. And that's going to give me my horizontal distance. Okay, so I would write x of a is 42.188 yards, and that's my horizontal distance. Now that's just a faster way to calculate that. Do I have to do that? No. What could I do? Well, if you want to go old school, which I don't know, maybe some of you want to go old school, you would type in 30 cosine 45, and then you would multiply it by our 1.988, blah, blah, blah. And you're going to get this number. Right? We just made the calculator do all that work for us because it's faster. Okay? And so that is where we were able to find the height. So now let's go back to the prompt. It says, when did the ball hit the ground? When did the ball hit the ground? What is that asking? Isn't it it's asking for the x-intercept, isn't it? And what mode do we have to be in to find intercepts? Function mode. We have to be in function mode. The parametric mode won't do that. So we have to, and we need to know how far horizontally did the ball travel. Okay, so let's pull the calculator back up. So we need to go to function mode. So mode, we're going to function mode. Oops. Alright, so we have our graph. And we want to find this location right here. We need to know when that happened. Because if we know when that happened, then we can know how far that was horizontally, right? So I need to do my zero finder. So second calc, we're going to do number 2 for our zeros. And I'm going to go over here and okay, so I'm to the left of the 0. And now let's go to the right of the 0 and make it work. Okay, so now our calculator believes that x is 5.5094. Okay, that's what our calculator believes, and we're going to store that. But let's go ahead and write that down. So we would say grounded at t equals 5.509 seconds, and I'm going to equate that to b. I'm going to store that in b. Okay. So let's do that. Let's go to a clear screen and let's press X and then hit enter. So our calculator now believes that's X. See how it just changes? I mean, X is something different all the time. So we're going to store it. We're going to store it as alpha B. And now it wants our how far horizontally did the ball travel? What could we do? We need to pull down the x equation, right? We need to be back in parametric mode. So go to mode. Let's go back to parametrics. And so now let's pull that. Actually, I can even go up and highlight that and then just change that to B. So I want x1, which, okay, so we probably need to do that again. So alpha calc x1, that's how we get to x1, of B, and that's going to give me my horizontal distance. So x of B So what I'm notating here, what I'm telling the person who's looking at my paper is that I used the x equation and I inserted that value b in. That's what this is telling, and that's the only work I need to show. I just need to say x of b is, and it's what, 116.865 yards. This is the horizontal distance. Okay, how is that? We okay with the calculator input? Okay. So we have one more problem to work, and on this next problem I'm not going to do all the calculator input, just to save time so that we have more time to work on our daily work. So hopefully we're okay with the calculator input. If you have questions, you certainly can ask me as we're working on our daily work, but I'm just going to go ahead and close the calculator down, and let's look at this next problem. So we have from a point 30 yards directly in front of a 10-foot goalpost, a football is kicked with initial velocity of 60 feet per second and an angle of 30 degrees with the horizontal. Okay, we want the angle to be with the horizontal, so that's fantastic. I'm going to draw a little picture. Okay. That's 10 feet. I have great artistic ability, right? Sorry, that's about as good as I can get. So here we're kicking the field goal. This is 30 yards. But I actually would rather be in feet. Look, my velocity is in feet. So why don't we go ahead and change that 30 yards. That's going to be 90 feet. Okay. So let's write our equation. So we have x equals, our initial velocity is 60 feet per second, and x goes with the cosine, 30 degrees t. We're not going to do a horizontal displacement. Then we have y equals, so we're in feet, so what's that acceleration due to gravity if we're in feet? It's 32, right? So 32 times a half would be 16, so it's negative 16 because negative is in the formula. Negative 16 t squared plus 60 sine 30 degrees t. And then do we have an initial height here? The ball is on the ground, so we don't, right? So there is no why not. It just stops right there. So I would enter those equations into my calculator in parametric mode and in function mode, the y when in function mode. So will the player make the field goal? Well, what I need to know is what is the height when the ball is at 90 feet? That's what I need to know, right? How high is it when the ball's at 90 feet? Then I'm going to be able to tell whether he made it or not. So if the height is over 10 feet, yes, he made it. If it's under 10 feet, no, he didn't make it. So I need to use my horizontal displacement equation. I need to say 90 equals 60 cosine 30 degrees t. I need to find that t. I would use my calculator. I would solve for t, and I would just enter that into my calculator. 90 divided by 60 cosine 30 degrees. And so what that's going to give me is 1.732 seconds. And I'm going to equate that to A, and I'm going to store it as A. Okay, so now I know when the ball's at 90 feet horizontally. Now what I need to know what is the y value at that time, right? How tall, how high is the ball off the ground? So I need y of A, and I'm just using this y equation. I'm going to pull it down. I would put it in my calculator. So y of that time A ends up being 3.9615. That's the ball's height at 90 feet. Does he make it? No. Okay, so we're going to say no, but that is not a sufficient answer. Just the word no is not a sufficient answer. I'm just letting you know. You have to explain. How do you know? Well, I mean, lots of different explanations would work, but I'm going to write, what I wrote was at 90 feet, the ball was 3.962 feet high. Not enough to clear the 10-foot goal. Okay, so that gives us exactly what's going on. So now, are we okay with that? Okay, and you don't have to use the words that I'm using. You can use whatever words. You just need to give me a sentence explanation. Look where English and math are matching, okay? You actually need to use a sentence to explain what's going on. All right, so the last, it says, when and where does the ball hit the ground? So that's similar to this other question, right? We need to know the x-intercept. So I would go back to function mode. I would find the x-intercept. So we do that, and so ball hits ground at t equals 1.875 seconds. I'm going to equate that to b, and I would store that in b. So it wants to know, where does the ball hit the ground? Where do we need to go now? To our x equation, right? Our horizontal equation. Where does it hit the ground? That's a horizontal question. So I would do x of b equals, I'd put that in my calculator, and I get 97.428. Oops. 97.428 feet. And this is my horizontal distance. Okay, so how are we with parametrics and calculators? We understand we have to go back and forth and which we use. Okay? All right, great.